Hello, today we're talking about one of the classical computer vision algorithms used in video analytics, and that's background subtraction. So let's take a look what it is. All right, so background subtraction. Background subtraction used to be the core algorithm in the video analytics application. Nowadays, it's used less and less with the emergence of deep learning models and object detection, object classification, but it's still being used because it's very efficient and not very resource intensive. So it is still being used in combination with object detection, object classification algorithms. So let's take a look at what it is. Well, essentially, background subtraction is the process of distinguishing the foreground from the background. So what you want to do, you want to, for each pixel in the image, determine, is this part of the foreground or is it part of the background? And there are a range of algorithms how to do this. So let's take a look. First, let's look at an image of a typical video scene. Here we have two people walking down a corridor. So the goal of background subtraction is to assign for each pixel in this image a value that says foreground or background. And we're going to do this just binary, where we say foreground is white and background is black. So this is called a background subtraction mask, or a foreground subtraction mask, or a foreground mask. So if we do this on this scene here, what we're going to get is this. So basically, it's a black and white image. Each pixel that is foreground is white. Each pixel is background is black. And what you will also notice is that you will have gray pixels as well, because in this case, we do background subtraction with shadow detection, because shadows are actually things that are moving in the image. So a typical background subtraction model will detect this, but they're not really part of the foreground, or not very useful part of the foreground, because it's just an effect of the object in the scene. And in the end, you want to use background subtraction to find out which objects are foreground and which objects are moving in the scene. So this is why you apply shadow detection algorithms to assign to the pixels as well if they're part of a shadow that's part of the object or not. So how do you detect this typically, the background subtraction? Well, the most popular one is called mixture of Gaussians, which basically is a kind of a model different than a deep learning model. It's really just an internal simple model that models background pixels and different states of the background. And the background is defined by something that is not moving. So over time, for each pixel in the image, you update this pixel and you see, okay, it hasn't changed, hasn't changed, hasn't changed. And if it hasn't changed for a long time, you basically say, okay, this is part of the background. And you might have different backgrounds in order to account for things that are a little bit moving. For example, a tree that's moving in the background. So you might have a separate model for this moving tree, where you say, okay, it's part of the background, but it's a little bit moving, but it's not moving so much that I really think it's part of the foreground that I want to detect. And you might have a few others. So typically, mixture of Gaussians has about 4 to 5 models of the background. And if you look at the current frame, you then look for each pixel, where does it fit in my model? Does it fit into my 4 background models or 5 background models? Because then it might be the tree that's just moving, or it might be the car that's just standing around, it's not moving. And we say, okay, it's part of the background. But if it's not, then it's part of the foreground. And basically, we're doing a subtraction between the background model and the current frame. And the difference between both of them is the pixels that do not fit into the background model. And that's exactly the pixels we see here and that are marked as white. If you want to do shadow detection on top of this, there's a few tricks that are very classical image processing. For example, you look at the different color values, where you look if the hue is the same as the background, but the saturation, for example, is not, or the lighting. You also look if the pixel maybe has more of a blue component, which is very typical for shadows, especially in outside environments. It's not perfect, and that's what you see here in this example. Not for every pixel we correctly identified that it's shadows, but it improves the results, so to say. Okay, so what do you use this for? Well, this is typically being used as the first step in object tracking, where this gives you the range of pixels that are interesting. So based on this, you would cluster these pixels together to figure out which of them are actual objects with some connected components, or some kind of clustering algorithm that tells you all these pixels belong together. And based on this, you would then do object tracking and try to follow this object through time. So this is how it was classically done. Nowadays, since it's so resource efficient, it sometimes is being used as a first step to identify which areas of the image are interesting. And on these areas, you can then apply object classification, which you might run maybe only once per second, or maybe every once per 5 seconds, or once per object. So you might use this to track objects through the scene and then just classify them and say, okay, this is a car or this is a person. And this way you can combine classical computer vision image processing techniques such as background subtraction with modern object detection, object classification models, get a similar type of accuracy, but much faster than if you would just do classification each single frame. All right, so this is the very quick summary of background subtraction. It's a super classical image processing computer vision method that has become a little bit less popular, but is still relevant in our applications today. I hope you enjoyed it, and I hope I see you next time.